Hi, welcome everyone to this month's second Tuesday session on match color, how to match any color out of a library or a measured color on any printer. So this is going to be a live demonstration. I'm going to be showing it on a inexpensive HP color laser printer. And we'll talk about some of the issues related to an inexpensive printer. But the beauty of this is that if it can work on this printer, it can pretty much work on any printer. So in our scenario, we're going to be matching these stickers so that I can put these stickers onto the color after I've printed them so you can actually see how close the match is. And of course, we'll be measuring the color with an instrument and it will tell us how close it is as well. And this process is a multi-step process, as you'll see, and we're using ChromaChecker Capture. So I'm going to log into ChromaChecker Capture right now, and I'm entering my operator login. And the way my capture is set up is it brings me into Print Inspector. I'm going to click on the purple button to bring me into what we call our Quick Checker module in Capture. You can configure from the cloud for Capture to open up in whichever module you use most. So if you only use it for measuring substrates, you can have Capture open up into the substrate inspector. If you're using it for matching color, like I'm doing here with Quick Checker, you can have it come right into Quick Checker. And the first thing I'm going to do is I'm going to measure this cyanish patch or sticker. So I'm putting the instrument on the sticker, I'm measuring it, and you'll see up comes the color here, and it automatically names it Cyan 636. And by the way, if anyone has questions, please feel free to enter them in the chat, and Beth will interrupt me and have me answer those questions. So I've got this color scanned. Now I have to save it into a library or a palette so that I can start the color match on this color. So I'm going to go in and make a new palette, and I'll call this new palette stickers, and I'll let it name it Cyan 636. And when I say save, it will save it to the library. Now I'm going to go to my source of reference and change the assets and choose that stickers library. And up comes that cyan patch that is the first color in the palette that I'm going to try to match to. Right now, obviously it's 0.0, but I'm going to print a sample of this on the printer and then measure it, and ChromaChecker will tell me how close it is. So at this point, I'm clicking on the Start Color Match. And in the Start Color Match, it says, okay, select the reference and set up the color space. So the color space on this printer is an RGB printer. Typically, if a printer has a driver, and I'll be printing this sample through Photoshop, but you should be able to print it through something like Acrobat or some color savvy application. And if it's going through a driver, it's typically an RGB printer. Like I have an Epson P5000. If I'm sending data to that printer through my driver, it's set up as a RGB printer. But if my printer is a RIP, like my Epson, I can also print on my Epson through two RIPs I have. One is driven by a RIP called EFI, and one's Print Factory. In that scenario, the printer would be a CMYK printer. So in this case, it's an RGB printer, so that's what I've chosen here. And now I'm going to choose the RGB profile that represents this printer. I built a profile for this printer using a 400 patch target. I wish I had it here. It was measured with the i1, took me about 5 minutes. And we should probably have another session just on that if you want to see how that's done, because it's very easy, especially if you have a scanning device like a Exact or an i1 or a SpectraDens. If you have a spot device like a Nix or a spherical Spectro, it might take a little longer to do a 400 patch target, but it'll save you time when you're trying to match color like I'm doing here. Now, since it's a 400 patch target and it's a fairly imprecise printer, it might take me a couple iterations to get the right color. But if I had built a profile using a larger target, like a 16-17 target, and it would have been on a stable printer like an Epson, our feedback is that customers are getting less than a 1 delta E match the first iteration. So in this case, we'll see how we do. So I'm saying print the PDF. And what ChromaChecker is actually doing is it's saving the PDF into a folder that I've designated through this purple button in the lower left-hand corner. And it automatically put this PDF called Color Match Cyan 636 with today's date and time right here. Now I'm going to open that up in Photoshop. So I'm going to open the Cyan 636 in Photoshop and then print it through Photoshop. So I'm opening it up as an RGB file. Now I'm going into print, and my Photoshop settings are set up for Photoshop manages colors. And then the printer profile is the printer profile I built within ChromaChecker, and I saved it in my profiles directory so Photoshop can see it. And then my rendering intent is absolute colorimetric. And now I'm going to print this swatch, if you will, out on the printer. And in a few seconds, it should be coming on the printer if I hit the print button. And here it comes. And now, after it's printed, I'm going to measure the result and see what the value is and see how close our first iteration brings us to matching this cyan sticker on my swatches here. So here comes the print. Here's the cyan simulation. You can put the sticker next to the cyan simulation. Beth, how's that look? Does it look pretty good?
Yeah, I'm looking at you in a small window, but pretty good in the small window.
Okay, well, for those of you with Skype, you can size the window to be smaller. In fact, let me just stop share so we can, for people who don't want to do that, here's the match, the first match. And
that's pretty good.
It looks pretty good, right? So, but let's measure it. Let's really see what it is. So I'm going back to share screen. And so right now I'm taking my I1 and I'm directly putting it on the print, and I'm clicking the button and up it comes and it says it's a 3.8. Okay. So not the greatest. I mean, it actually looks better than the number shows me. So I'm going to have ChromaChecker iterate this a second time. So I'm going back into saying print my PDF and making sure that it did print it. So I'm clicking on different screens here, so I have to make it active. So it did print it this time. I'm going back into Photoshop and I'm opening up the new iteration that I just built, which you'll see here is a little bit, a couple minutes older than the last one. And when I open this file up, you can see when I put them side by side, they are a little bit different on the screen. You can see a visual difference. And now I'm going to print this with those same settings. And now we'll have our second iteration out of the printing device. So the device is warming up. It's printing it.
So Dave?
Yeah, question?
Someone asks, you're using Photoshop because you don't have
a RIP. That's correct. I'm using Photoshop because I don't have a RIP for my HP printer. Okay, so here's my, that's a good question. So now here's my next iteration of the color. And you can see it is a little bit different. It's a little bit lighter. And I'm going to take my measurement device and put it on. I'm trying to aim for the same place on that square because you'll see in a minute that this printer is not completely consistent. And look at that, I'm down to a 1.7. So in the bottom left-hand corner of the screen, you see I'm a 1.7 in terms of the delta E or the level of match. So I greatly improved the match, but let's do it again. Let's see how close we can get. So I'm hitting the print PDF again, going back into Photoshop, opening up my third iteration, which is right here. And again, you'll see it's a little bit different again. And we'll say print. And in what? A couple minutes? In fact, I'm going to mark these. I'm going to put a number 1 around the 1, number 2 around the 2. And then this is my third iteration coming out the printer right now.
Hey, Dave,
Yeah.
question. Can we print from Adobe Reader as well, or is Photoshop required?
So that's a really good question. Ideally, you should be probably Acrobat Pro. You can do it because Acrobat Pro has color management capabilities in it to turn on like absolute colorimetric rendering to know it's rendering the right color. Reader, I have to do a little research to see if we can do it with Reader. All right, so here's my third iteration. And if we take a look here, we can see, you know, the match is really looking good now. And I should really be doing this in the light booth because my overhead lights are not D50. So remember, when you're doing these color matches, the profile default is D50. So it's a light booth white point. If you have fluorescent office tubes in your building, you can't do a visual look like this. You have to put it in the light booth. So now I'm going to go back and share my screen. So we see all at the same time what the delta E is of the latest match, putting my instrument on the color, and it goes from a 1.7 to a 0.5. Woohoo! So there I am, 3 iterations. I'm at a 0.5 with no, really no thought process, just hitting the buttons. And now at this point, I've got my color match. In fact, I can take my sticker and I can actually put it right on my color match. And so you can see the two should pretty well blend right into one another. How's that view, Beth?
That looks really good. Hey,
Pretty
I have
good?
another question.
Yes.
Yeah, another question. How do you know when you have reached the best color match possible with the device you're working with?
All right. So that's a tricky question. Now, could I iterate it again? Yes, probably. Might it be better? Maybe, but does it have to be at a 0.5? That's good enough for me. Anything under a 1, especially with a printer like this, I'd call it good. Now, you should understand that when we're actually taking the value. So let me just do this. I'm going to just finish this procedure. I'm going to create a new lookup table. And this new lookup table, I'm going to call it stickers for HP. And in this way, I have started a lookup table that I'll be able to apply in my workflow so that when it sees sticker cyan color, that it will automatically substitute it for the given printing process that I'm running on. All right. Now, we're going to do more with that lookup table and talk a little bit more about it. But to answer the question that came in here was, what can you expect? Depending upon the sample that you get, the uniformity of the sample will affect the color that you choose as a reference. If we take a look at this cyan color that's out on the printer, if you look at the left side to the right side, that color is not uniform. There's a variation in the color of the way it's printing due to the inexpensiveness of the printer. And ChromaChecker has a function called start variation. This is different than the start color match. This start variation helps me measure this color and check how much variation is going on the page. So I'm going to measure multiple times across the page. I've measured 4 times now, 5, 6, 7, 8, 9.
Dave, there's another question.
Yeah.
Do we have to worry about paper white when you're using this methodology?
Okay, so let's cover that in a second. So in this scenario, you'll notice that there's a 2.28 plus minus variation on the page. In fact, if we count the center of the page as 0, there's actually a 4.5 delta E variation between the left side of the page and the center of the page. Now, I bring this up because when you're deciding what is going to be the color that you're matching, if someone gives you a piece of paper like this and says, match this color, using the start variation, you can see how much variation there is on the page here. A 4 delta E variation within 4 inches is huge. And I would ask the person to draw a circle around the color they want me to match, just because there's so much non-uniformity on the page. I have this situation with a big box consumer electronics store, and they gave me a blue to match, and I measured multiple times on the sample, and there was like a 3 to 4 variation on the sample, and I'm like, where on this print do you want me to designate the original? So the start variation is a phenomenal tool for helping you see the amount of variation that's happening on any type of print process. And the variation is the average of all the colors. But when you have outliers like 4 delta E apart, that's too much variation to build a reference across, in my opinion. If you're living with a 5 delta E of tolerance, okay, maybe not. But if you're trying to get down to a 2 delta E of tolerance, if you've got 4 delta E going on the page, that's a big red warning flag. Now, the next question that was asked was, do I need to worry about the substrate white? In doing this process, no. In fact, when you're measuring the color of the sample, it's taking the substrate into consideration based on how dark that color is. And if you were then to print this on let's say, a darker substrate or a lighter substrate, the iterative process would go to match the color, not that it compensates for the change in the substrate. So the color of the substrate does not, you don't need to worry about it as a user in terms of doing this measurements. The software will automatically correct for it. That makes sense? All right, now let's do a second match. So now I'm going to stop variation, and I'm going to take my instrument, and I'm going to put it on the red color here, and I'm going to click on the red color, and up it comes, and it automatically names it Rose 642. And so the first thing I'm going to do is save Rose 642 to my stickers library. And that should be done now. Okay, so now I can start the color match. So now I'm going to attempt to match this rose color on my printer. And I have the ability to come down here and say I'm aiming for the rose color. Everything else stays the same. I say print PDF. The PDF was successfully saved. I go to Photoshop. I then open, I didn't want to go into browse. Let's go ahead and say, go back to Photoshop and open my rose color. Migrate to my folder. Here's my Rose 642, RGB, print, and wait for a few seconds for it to come out of the printer. And then I'll measure it and see how close we are on the first iteration of this color. So here comes my print. Here's my rose color. Take a look at it. Looks, in this light, looks a little orange to me, but let's go ahead and measure it. So I'm measuring my sample to see how close I got. Up it comes, ooh, 5.7. So yeah, not very close. So let's go ahead and now print this color again. And go back to Photoshop. And open the new print. And say okay. And now print, and notice it's darker, it's less orange. Definitely what I'm hoping to have happen. So let me get this printing and then I'll separate these two. And you see how this one's pretty orange, this one's a redder red. So again, because I only used a profile with 400 patches on this target, I might have to do a couple iterations. And oh, by the way, if you didn't even have a profile for this printer paper combination, and you have a generic profile, you can do the same procedure, but instead of maybe it taking 3 iterations, it might take 6. Big deal. It's just, in this case, it's cheap paper. And so here I look, and yes, this is definitely a better match. So, and notice every time I'm measuring with my ISO compliant white backing. You don't want all these papers are semi-transparent, so you definitely want to make sure you're measuring on ISO white backing. And now we'll bring my ChromaChecker screen to the front. My second iteration, as I click on this, goes from a 5.7 to a 2.6. Fantastic. I'm going to say print again for a third iteration. Go back into my Photoshop. Go ahead and open this third iteration of the rose color and take a look at it. We'll move it down and you can see it's different from the previous measurements. And now we'll print this out on the printer and be ready to measure this next sample in and see how well we do. While we're doing this, I'm going to mark this as a number 2. Mark the other one as a number 1. And here comes number 3. And we're going to take our measurement device, measure right on it, click it, up it comes, 1.8. So we're going to say, okay, this is fantastic. We're at a 1.8. And now I can go ahead and save it to my LUT with my cyan color on it. So I'll update the LUT. And the way this LUT works is this LUT is a lookup table, a spot color lookup table. So as long as my color that the designers are building within Acrobat, Photoshop, InDesign, they're named colors as spot colors or individual channels within those programs. When they print through the RIP with this lookup table applied to it, it says, oh, you're wanting this sticker cyan, and it knows the RGB or CMYK values to reproduce this sticker properly on this printer. And then you'd build another lookup table for a second printer, say make, model, different printer, what have you, and put a separate lookup table on that printer. And in this way, when you print the same spot colors on the 2 different printers or the 10 different printers, they will actually match one another. So we actually have a session that we've done in the color conversions where we talk about spot color conversions on a second Tuesday seminar. And if I back out to the ChromaChecker homepage, so let's go ahead to the ChromaChecker homepage, and we have a section on our website called the events, and you'll see their second Tuesday WebExes. And here is the conversion event, which talks about spot color conversions. So if you want to learn more about a spot color workflow and how that works, that's a good session to go to and listen to and learn more. Now,
Hey, Dave,
yeah,
I got another question.
okay.
What if I want to match a color from a fabric to a printer? Is it the same procedure? And is the i1 Pro 3 Plus suitable for this type of measurement and match color?
Okay, great question. Okay, so let's say I have a fabric. So I just happen to have a fabric over here on the side of my desk. And this is a type of wallpaper. It's like a fabric. And ideally, when you have this type of unevenness on the surface, you should be using a larger aperture device and potentially even a spherical device. Now, the spherical device allows us to measure substrates like foil. With substrate foil and mirrored properties, you can't use a 45-0 instrument like an I1 or an Exact or a Nix or a Peshcon. You've got to use a spherical device. Now, there's a fine line in terms of when you can get by with using a 45-0 device and when you need a spherical device. So we've developed a methodology, which we call the three-step process to know whether or not your instrument is appropriate for the given material. In fact, that was a second Tuesday seminar. If I come back here, you'll see it's the session here in November called When to Use Which Instrument. And I'm going to just quickly rehash this right now for the gentleman who's asking the question. And what you do, the three-step process is 3 ways to measure it. Typically, I do 3 separate variations, but today I'm just going to do 1 variation and kind of check it. And so we're going to go in and say start variation. And the first step is measuring the same place multiple times. In fact, I'm going to make sure I'm not even touching the instrument. So I'm just hitting the measure button from the screen, and you can see the repeatability of these measurements. The peak delta E is 0.17. So you want to make sure that the variation between these measurements is less than 20% of your overall tolerance. So if your overall tolerance is, let's say, a 2, then you want the maximum E factor variation or 95th percentile E factor variation to be less than 0.4, which is 20% of 2. So in this case, in step 1, it passes. Step 2 now, I take the same orientation and just measure in different locations on the page and see how much that varies. And you can see the E factor jumped up to 0.24, up to 0.3. So it's higher, it's climbing up to that 0.4, but it's not there yet. So now I'll say it passes step 2. Now step 3 is I'm rotating the instrument or the substrate around the measurement. And as you see me doing this, you see the E factor blew up. So the E factor is up at 0.91, which if that's 20% of your tolerance, that means multiply that by 4, you're at a 3.6 tolerance for trying to match this. So technically, if you're okay with 3.6, then you can get by with a regular I1, because this is the smaller aperture I1. If I would have done this with the larger aperture I1 and the numbers would have been smaller, I might have been able to do it. Or if not, I would have had to use a spherical device, because the spherical will handle this no problem. So we'll just go ahead anyway and say, you know what? I know I'm going to be limited due to the lack of the aperture for this, but let's actually try to match this color. So I'm going to stop my variation, and then I'm going to save this to my assets. So I'll save this, and I'll do it to my stickers assets. That's fine. And we'll say save. And now we're going to go ahead and hit start color match. And I'm going to set my variation 647 here. And we're going to print a PDF that's meant to represent this fabric color. So going back into Photoshop, now I'm opening up this fabric simulation. Variation 647 is what we're calling it. And we're going to print it. And out of the printer. We wait for it to come. And then we're going to measure it and see how close we got. So here it comes. Now, I obviously would have had a better match with a larger aperture device, but sometimes you have to work with what you're given. And that's what we're doing here. Now, take a look at this. So you take a look at the fabric versus the match. And again, I should have D50 bulbs up here. It'd be a better match, but it's not bad. But let's see what ChromaChecker says the number is. So I'm now clicking on this print, and it shows me it's a 4.0. A 4.0 is kind of what I was expecting here. So we're going to try to iterate this, because remember the E factor variation was like a 0.4, and therefore it's 10% of that is 4. And that's what we actually got. So not surprising, but let's iterate off this color. So I'm going back into my capture menu, and I'm clicking on my next sample, and we're going to print it. And you see there's a slight color difference between these two samples, and our print's going to come out, and we'll measure it to see how close this sample is. Where's my pen? I'm going to put number 1 on this sample, number 2 on this sample. And we're down to a 2.3. So in this way, I can say print again. It does another iteration, go into my Photoshop, open the file, and print the third time. Third time's kind of the charm today. The third time is giving me a really good match, and we'll see how we do with this one. So we went from a 4 to a 2.3, which is a nice progression. And oh, by the way, the history of all the measurements I've done, by the way, guys, if you look over at the scratch pad, every measurement I've done since the start of this Zoom is listed on the left side here. So you can save that data, you can look at it, you can do more comparisons. It's always there for you. So here's my third iteration, putting it on the white backer, measuring the color, and we'll see here it goes down to a 1.5. In fact, just for fun, I'm going to kind of move my instrument around a little bit and see if different places on this give me a lower number. But a 1.5 is pretty darn good match, and I'll say, hey, I'm good to go with a 1.5. So as I it's funny, I'm looking for the 1.5. I don't have to look for it because it was right. I think it was this one here. There. That's the color I want. And then that's the color I'm going to store in my LUT. So I started hunting around to see if I could find that 1.5 again, and I wasn't finding it. So I could just go to my history of the measurements that I've done, choose it, and then I can go ahead and update my stickers LUT, or I can make a new LUT if this is a new job that I was working on. So in this way, it's very easy to set these lookup tables to accommodate different colors on different printers. Remember, you need a different lookup table for each printer substrate combination, but they're very easy to build. Yes, Beth, question?
Yeah, that question was, how does the system apply when you have to print this color to multiple printers profiles and color manage to Grackle 2013?
Okay, so essentially, if all the printers are matching Grackle, it really doesn't matter. It comes down to the spot color matching. So as long as the spot color that we're measuring, such as this fabric or these stickers, are within the gamut of the printer, meaning each printer has a different range of color that it's capable of producing. And if you want to learn more about this, I go to our 5 C's learning color management, and it talks about the gamut, the range of color that every printer paper combination has available to it. As long as the color that we're looking for is within the gamut, then we should be able to match that color using a spot color lookup table. And the printer, if it has a rip, it'll simulate the CMYK data, meaning the images and CMYK built artwork to Grackle, but the brand colors, the spot colors, we want matching to the actual originals that we're telling it to match to. So with a typical printer rip combination, the process work goes through the Grackle simulation, and the spot goes through the spot color lookup table, which ChromaChecker is building, and it is applied through a print factory rip or a EFI rip or an Onyx rip. And in this way, you match both Grackle for the CMYK and the spots using ChromaChecker spot color lookup tables. Now, a question that comes up related to gamut is, let's say I've got something like this Ritz cracker box, and I want to see if I can print this Ritz bread on this printer. This is like a bright Pantone color, like 185. And I doubt I can print this on the printer, but we can check, we can see. So what I'm going to do is just say stop color match on this fabric sample, because we're at a 1.5, that's awesome. And now what I'm going to do is take my I1, measure on this Ritz box on the red, and you'll see up it comes on the screen. There we go. And now ChromaChecker's added a new capability. Those of you that were able to attend our color conference, what, a week and a half ago, everyone had a great time. We introduced this color match function, and we already had a number of customers get back to us saying, this color match function has saved hours off their workflow in terms of matching colors. That's how great this is. Now, this is another new capability that we built. Is that, okay, let's say I measured this color and I want to see whether or not this color is capable of being printed on my printer. Because the colors I chose on the stickers, they were kind of subdued colors. I did that on purpose because the gamut of this printer is not very large. Now, this signal red is going to have trouble on this printer. And if I go to my CMYK profile, and I come down here and choose the profile for my printer, it's going to tell me that the closest color that I can get is, drum roll please, I say get closest value, it shows me it's 3.0. So 3 delta E is the closest that this color can hit this Ritz red, which means I can go ahead and do a start color match on this color and go on the printer. But once I get to 3, that's as good as it's going to be, because ChromaChecker here is telling me that this color is 3 delta E outside the capabilities of the gamut of this printer. All right. So, and FYI, tells me the CMYK values here are about 12.6, 100 magenta, 81 yellow, 3 black. If I use that CMYK value in my InDesign, whatever, when I go to print, I'll get about a 3 delta E to the Ritz red, and that's as good as I could hope to get. Now, obviously, that CMYK build is based on the profile, the condition that the printer was in when it was profiled. So doing a start color match iterates it and accommodates for the fact that this printer is not printing the same way as it was printing when we built this profile 2 weeks ago. It doesn't matter. It'll iterate to the closest that it can get, and just know, yeah, we might be able to get a 2.9, but I really doubt it would be any better than that for this printer. So in that way, you know what's possible and what's not. Where not to waste your time in terms of trying to match color when the printer just can't do it. If you have a high delta E like this, I would recommend getting a higher quality paper. maybe a higher quality paper with a higher lightness value. The lighter the color is on the paper, the more money the paper is going to cost, but also typically the more gamut that the ink on that paper will give you. So that's another thing to think about. If boy, you know, your customer wants a 2 and this printer is limited to a 3, now you have to figure out another printer to use to get it. Well, maybe by upgrading the paper to a higher quality paper, you might be able to get it. I can tell you, I bought this paper specifically at the best L-star for this printer. So I'm showing this printer in its best light. I don't think you can get any better than a 3, but that's an HP LaserJet. All right. So Beth,
Okay, we
any
got
questions?
yeah. So what is the directory path where the PDF save of the print PDF button? Can we modify where it's saved?
Great question. And yeah, I went over this quickly earlier, but if you look down in the lower left-hand corner of ChromaChecker, this button right here is the export folder. And by clicking on it, I can open up the settings, and this allows me to change the folder, open the folder, or turn this function off. This way, if someone has set up, like, let's say, an automatic hot folder with their Acrobat or their Photoshop, every time I print the PDF to that folder, it'll automatically send it to the printer. I wouldn't even have to go into Photoshop and say print, open and print. So that's a really handy feature. If you're going to be doing this a lot, you can set up a Photoshop action to automatically print out of that folder. The other thing I want to show here is the variator and the snowflake. So with ChromaChecker, you have the ability to create a variator. And what this does is it shows me every iteration of, in this case, delta E's in half-step increments, plus minus from 3 delta E. So it'll show me a 1.5 delta E, 2 delta E, 2.5, 3, 3.5, 4, 4.5 delta E. So it'll give me 6 pages with all of these iterations. And I won't take the time to print this. I'll show you what it looks like when it's printed. It looks something like this. So let me stop sharing my screen. And what this allows you to see is, in this case, it's all combinations of a 3 delta E. And for this color, it shows you every possible 3 delta E. And I'd like to show this sample because all 3 delta E's look pretty good, except that one and that one. The differences between the center and the inside ring here, which is the reference, and the center and the inside ring here, which is the reference, that looks like it's more than 3 delta E. And that's the problem with delta E, is that it's not linear to how our eyes see color. And so you can say, Mr. Customer, will you accept a 3? And they'll say, yeah, but not there and not there, which means you have to go to a 2.5 or a 2 delta E of tolerance, which, if you're in production and you're trying to manage color to a 3 delta E or 2.5 to 2 delta E of tolerance, you just got a headache, because your waste just went way up, your time and effort went way up, and there's times where it might be a 3, but it's going to pass, and so you're making pages that are sellable, but you have to fail them because they're asking for a 2.5 delta E. Well, this is where a snowflake tolerance comes in. A snowflake tolerance allows you to have a greater degree of accuracy on a color match than what delta E provides. I was on the committee that tested the delta E formula versus delta E 94. And although delta E 2000 is much better than delta E 94 in most colors, there's certain colors it actually got worse. But the formula is so convoluted, no one had any idea on how to make it better. And hence, no delta E has been updated in 24 years. The best delta E we have is from 24 years ago. And so this is where a snowflake tolerance comes in, because the snowflake tolerance allows us to set the tolerance based on individual L, A, and B axes. So it's literally 6 times more accurate than straight delta E. It's delta E tries to combine all these in one. This is what we call snowflake, is a delta plus minus L plus minus A plus minus B. And you print out your snowflake, and then you can say that, boy, I don't like where, even though it's 3 delta E, I don't like it here, 3.5 delta E. I'm gonna keep the tolerance from going above this level. So you limit the L star, and you let the A and the B go to a larger area. So theoretically, well, no, practically, you're getting a larger range of color acceptance when you're measuring with metrics, when you're measuring with an instrument, which gives your manufacturing area more room for latitude and variation in the print process, which we need, which means more sellable sheets off the printer that meet the customer's expectations. That's what ChromaChecker is all about, is meeting customer expectations based on their visual match. We've had this set up with process colors with E-factor for years. Our users love it and wouldn't do it any other way. Well, now with spot colors, with the snowflake tolerancing, you don't get false fails. That costs you time and money because the delta E is wrong, even though the delta E is unacceptable, even though visually it would have been okay for the customer, but because you can't put a sticker on saying it's the delta E that the customer asked for, you've got to throw the print away. That's crazy. That's why printers are losing money. That's why you want to use ChromaChecker to overcome these special color situations and produce more sellable work and make more money. So Beth, any other questions? It looks like that's
So we passed it. There was could you show me in the print inspector how to configure and perform the first measurements with different printers?
okay.
And then also someone was interested in how do you set and track the coated paper?
Okay, so let's just quickly show snowflake. So I'm going to just build a snowflake quickly, go to my Finder, go to my Photoshop, open the snowflake. And this snowflake I made a little more sophisticated in that I'm showing not only the references in each color, and I did this for the red, but it shows the delta E's. So if I flatten this in Photoshop, so let's come over and just flatten it. And then you'll see that ChromaChecker is telling me what the delta E's are for this snowflake as we go out in the different dimensions for plus L, A, and B. And it shows you the sample. So here's the original, here's the deviation. It's 2.7 delta E, and it's -3 L star. And so in this way, this is how you can set your tolerance up in terms of matching color. And Tim Quinn did a session on this at our color quality conference, and it was really interesting how people drew their tolerance around this snowflake to have a custom tolerance based on visual requirements. Now, for the other two questions, they're kind of outside the scope of this presentation, but essentially in the substrate inspector, that you can go ahead and click on the substrate, and you can make a new substrate that you want to track, and then you give it a name, and then you measure that substrate, and it will trend how that substrate is performing in terms of when you get new batches in from the customer, you can see if that substrate is changing at all. You can also do that in conjunction with Print Inspector. So the other half of that question was, they want to measure a color bar, like let's say a CC84 color bar. So you go into the P here within ChromaChecker Capture. This is for measuring process controls. So the Quick Checker is more for quality control, spot color matches. Print Inspector is more for checking if the print is G7 compliant or ISO compliant. And I have all my printers that I've configured for me available on the left side. And then I can choose different tracks based on whether or not the track is full gamut or uncoated or coated. And then I can choose which color bar I'm using to do my measurements. And then at this point, I would just use my I1 to measure the color, and it will automatically give me a pass-fail compliance in ChromaChecker. And if your color bar has a paper white in it, it will also track the color of the paper in the timeline. So if I go to this timeline here, you can see this gray line on the bottom. This represents how this printer printed over the last 50 measurements. Shows me the E factor, shows me all 50 measurements. And as part of each measurement, it's tracking the paper individually or independent of the actual print on the paper. So this paper, this paper hasn't changed. It's pretty much been a 1 delta E the whole time. But if I go to another printer here, like the Inca, here's a large format printer, and I'm not showing it here, but sometimes these printers, you can see, well, here's the Epson. You can see that paper popped up here. The paper moves here. So the color of the paper was actually changing, and it can be tracked through the print inspector in that there's a paper patch as part of the normal color bar that you're measuring for your process control compliance. So very flexible here. We talked about how you can add your paper to your print track in, I think it was the last second Tuesday seminar. So you can review that or send a question to the help desk, and we can help you learn how to add that paper to your print track to really help keep your paper suppliers accountable that they're giving you the right paper. So I hope that you guys found this session helpful and educational. Great questions, you guys. Keep them coming in. And if you have ideas for topics for next month's second Tuesday, please submit those as well. Anything else, Beth?
Oh, that's all we got.
All right, that's a wrap, guys. Thank you. Hopefully see you next week or next month.